The boy had a hard time shopping because he was indecisive of which jackets, sweaters, and shoes he should buy. Out of all the clothes he liked, three Out of all the clothes, he liked 3 jackets, 2 sweaters, and 5 pairs of shoes, but can only pick one of each. What is a possible system configuration? So we're gonna use the fundamental counting principle, and since we have 3 jackets, 2 sweaters, and 5 pairs of shoes. And if you multiply that out, here's 6 times 5, 30. He has 30 ways of picking which clothes he should buy. The next question reads, a boy wanted to pick 10 shirts from a box without looking. How many different ways can the shirts be chosen if he only wants 5? So, right here we're going to be using combinations. And always the bigger number is always the n. So that's what helps me. So since there's 10 shirts, that's a bigger number, and the smaller number is 5. But you have to know why it's 5, because that's how many shirts he wants, and 10 is the total number. So we could do it by hand or plug it into the calculator, but I'll plug it into the calculator. 10, 5. He has 252 different ways. The next question reads, a boy goes to the store and sees 14 pairs of shoes, 8 jackets, and 10 sweaters. He planned on getting 5 pairs of shoes, 3 jackets, and 4 sweaters. How many possibilities are there? So right here, we're going to be using combinations with multiple events. And so it's kind of like the previous one we did, but it says it's going to be multiplied. So it's kind of like these past 2 concepts together. So there's a total of 14 shoes, and he wants 5 of them. There's a total of 8 jackets, and he wants 3 of them. There's a total of 10 sweaters, and he wants 4 of them. So now you just do the NCR, and we'll use our calculators to make it faster. 14, 5, that's 202, 2002. 6. And the last one, 10, 4. So now we'll multiply all that times 56 times 2002. And our final answer is 23,543,520. The next question reads, the boy goes to the store and sees that there are only 5 shirts left. If you can only get 3, how many possibilities are there? So it's the same thing as it's really similar to combinations. Instead of a C, it's a P. So, and again, it's always a bigger number, N. And so he sees 5 shirts, You can only get 3. And we could use a calculator for this. 5, 2, 3. You have 60 different possibilities of getting the shirts in the box. Different shirts. The next question reads, how many distinguishable ways can the letter in boy be written? So here we're going to be using factorials and permutations. And there's three letters in the word boy. So it'd be 3. And there's no repetition, so it's just 1 factorial, 1 factorial, 1 factorial. This is 3 times 2 times 1. This is 1 times 1 times 1. 6 over 1. There are 6 different ways to rearrange the word boy.